At the bottom of the ocean, where few creatures dare to go, lies one of the most extreme environments on Earth. Where the ocean crust spreads and magma rises to replace it, there lies a type of geologic system called a mid-ocean ridge. Along the ridge, there are fissures, or cracks in the earth, that continuously emit streams of hot, mineral-rich fluid, depositing the minerals to form chimney-like structures of up to 18 meters, or 55 feet tall. Welcome to Beyond the Twilight Zone, a podcast where we explore the strangest things at the bottom of the ocean. During this episode, we'll be talking about hydrothermal vents. My name is Malaika, and I'll be one of your hosts today. My first co-host, Hunter, will give a case study of the Endeavour Area Vent System.
Hi.
We'll be tying all of our information to this case study, giving you a chance to connect everything to the real world. Next, Anjali will get a chance to speak about vent ecosystems.
Hello.
Facing no sunlight, extreme temperatures, and pressures that would kill almost anything else on Earth, chemosynthetic organisms thrive, developing mutualistic relationships with each other to make use of the resources that they do have. Anjali will go in depth about these organisms, giving some examples of the Endeavour region's surprising biodiversity. Finally, Isadora will give us some insight into the human aspects of the vents.
Hi.
What resources do they provide? How do we access them? Can we access them? And should we even try? Hunter, why don't you start us off?
Thanks, Malaika. So Canada actually has its own hydrothermal vent field. The Endeavour area is a mid-ocean ridge system off the coast of Vancouver Island, British Columbia, along the spreading boundary between the Juan de Fuca and Pacific tectonic plates, as marked on this map. The area is full of fissures, trenches, rocky protrusions, pillow lavas, outcrops, and sulfide towers. This area has many large black smokers, typically in excess of 300 degrees Celsius, with lower temperature zones surrounding it. The vent fields in this area exhibit a range of hydrothermal conditions, including different water temperatures, salt content, sulfide structure, and animal abundance.
I'm glad you brought up black smokers, Hunter. There are actually two types of hydrothermal vents, white smokers and black smokers. The difference lies in the chemical composition of the chimneys. The plumes of the white smokers, as shown on the right, are light and contain barium, calcium, and silicon. However, on the left, we can see that the plumes of the black smokers are hot and dark and contain high quantities of iron sulfide. How many of these chimneys have you seen in the Endeavour region, Hunter?
So researchers from the Monterey Bay Aquarium Research Institute have shown that there are almost 600 chimneys in the Endeavour area. So this Canadian vent field has some of the tallest chimneys known in any mid-ocean ridge, with the tallest having reached over 45 meters tall and being named Godzilla. These vent fields were mapped using sonar on ships and underwater robots, but the resolution of these images were not quite high enough to detect the individual chimneys on the seafloor until the MBARI's AUV, the autonomous underwater vehicle. Based on their work at Endeavour and other ridges, researchers have proposed a possible three-stage cycle for hydrothermal vent fields. The first is a magmatic phase that can last up to tens of thousands of years, where the magma erupts from the seafloor. The next is a tectonic phase, which can last up to 5,000 years, where the seafloor cools, the valley sinks, and cracks in the seafloor form. And then the last is the hydrothermal phase, which can last a few thousand years, where we see the hot fluids percolate in the cracks and then rise through the seafloor to form the vent chimneys, as seen in the diagram. This is the phase that the Endeavour vent fields would be in currently. Now I think the question becomes, how does life exist and thrive in such a harsh environment?
Why, thank you for asking, Hunter. So, specifically, at the Endeavour area, it is home to around 60 distinct native species, and many of these were the first to be discovered in the world. Of these species, there are 12 that cannot be found anywhere else on the planet. So, as shown on the screen, the Calyptogena pacifica, which is a type of white clam, it only inhabits the Juan de Fuca ridge. It benefits from a symbiotic relationship with the chemosynthetic bacteria. These bacteria convert hydrogen sulfide into organic sustenance and are one of the most important organisms within the hydrothermal vent habitat. The microbes are able to convert the inorganic chemicals to food, which is why they're so useful. Another fact about the Endeavour area is that an organism located here holds the current record for living in the highest temperature ever, which happens to be around 120 degrees Celsius. Pretty hot.
Wow. Okay. So what other types of organisms can you find at hydrothermal vents?
Well, it's funny you ask, because you can find all sorts of organisms that live near these hydrothermal vents. For example, there are many different types of microbes, tube worms, clams, mussels, shrimp, and even snails. And some of the major predators that live here within these ecosystems are giant crabs, zorsid fish, and the occasional octopus. So, one interesting fact about a species of crab that live near hydrothermal vents called the kiwa crab is that they are known to rhythmically sway their bodies around, which is thought to help improve the flow of methane and hydrogen sulfide from the vents. And at the Juan de Fuca Ridge, it has been observed that close relatives of a type of tube worm, the alvin-elid worm, have been found also near the Galapagos Ridge and the East Pacific Rise. And all these organisms can survive within this harsh ecosystem because there is such an abundance of food in the form of energy. The food chains at these hydrothermal vents are run not by energy from the sun, but by chemical energy. And the energy within the hydrothermal fluid is used by these organisms for metabolism.
Beyond energy, they also have resources that could be used by humans, right?
Yeah, exactly. Hydrothermal vents have over 1,000 times more copper, zinc, lead, and gold than typical deposits on land. They can also have significant amounts of silver and barium, and some quantities of cobalt, cadmium, indium, gallium, and germanium. Why do I care though? And why should you? That's because we need these materials for our phones, for computers, for microwaves, for cars. I could go on and on with just about any technology that we use. So suffice to say, there's been a lot of interest in deep sea mining near hydrothermal vents to try and collect some of these abundant and much needed metals. To actually mine though comes international territorial issues. Who actually has rights to the sea floor?
Actually, even in Canadian waters, there are some regulation issues. So the Endeavour area has been proposed as a federal marine protected area, but it doesn't yet have protections from future mining interests.
That's a great point, Hunter. So even if mining companies can overcome these rights and access issues, you still need to acquire the immense investment needed for the mining technology. On screen here, we have an image taken from a submersible used in mining and exploration. Anyways, back to the problems surrounding mining. I think that even if you overcome these political, economic, technological issues, there's a greater problem here, and that's the environmental impact. Anjali talked about the amazing ecosystems near hydrothermal vents, but it's known that mining would involve scraping the seafloor and churning sediments, which would essentially wreck these rare and unique habitats, threatening the species that live there. Beyond that, noises, vibrations, and possible chemical pollutants would most definitely impact larger organisms like whales and fish.
And don't forget, we must keep in mind that for these various types of mining, the destruction of these areas and ecosystems is going to be irreversible, and the recovery for that is not expected within our lifetimes.
So, given all of what you've said so far, how likely do you actually think it is that mining near hydrothermal vents will happen?
Well, there's already been one Canadian company, Nautilus, that won a contract to do mining off the coast of Papua New Guinea, but then they went bankrupt before they actually started any drilling. So, I mean, that's not the best example, but despite Nautilus's unsuccessful only growing. So I personally think it's pretty likely that we'll be seeing this type of mining more and more often in the future.
That's really interesting. Sounds like an area to watch out for. Over the past episode, I hope that we've convinced you of the importance of hydrothermal vents. Despite what may seem like a dearth of information, we've only really scratched the surface of the depth that you can go in on the vents, pun intended. There are several unanswered questions that remain regarding their chemistry, biology, geology, as well as their possible social value to us. We may not be able to answer these questions now, but maybe you will someday in the future. This is Beyond the Twilight Zone. Tune in next week when we talk about oceanic trenches and the future of ocean exploration. Bye, everyone.
Bye.
Bye.